Hey guys, welcome back. This video will go under the playlist PRACH. The learnings. So we will mainly learn about one critical design aspect of PRACH detector, that is threshold setting. Okay. Before I start, I want to mention that there are many people who are not subscribed and they're watching my channel. I would say if it is really adding value to you, please do subscribe and press the bell icon. It will add a lot of motivation to me to bring in more and more videos. Okay. So before I start, I want to mention about this PRACH configuration index because this will talk about the SFN and the slot number. Okay, this will set up a expectation for G0B in the sense that G0B would be expecting the PRACH reception on any of these slot numbers and SFN. Okay, what about UV? So it is giving an indication to the UV that you can choose any of this slot in a particular SFN and transmit the PRACH. Okay, so having understood this, I will take one example scenario where UV1 has chosen preamble ID number 1 and UV2 preamble ID 2, UV3 preamble ID 3, and all are transmitting the PRACH with the same power. Okay, so UV3 is further distance, UV2 is a little bit closer, UV3 is much closer to base station. Considering this into aspect, definitely the power the power of the signal coming from UV number 3 received at base station will be low, right? So among the UVs, the power relation can be given by this equation. Also, since UV3 is a further distance, so the timing advance or timing delay relationship can be given by this, right? Because it takes more delay, so TA3 will be larger. Of course, there are some UVs which might be very close to base station, or there could be some more UVs which are further, which could be at the cell radius and things like that. But I've taken only this example. So with this example, let us say for a given PRACH, G0B is expecting on slot number 1, 4, 6, and 9 that the PRACH can come. Okay, that is the expectation from G0B. Now let us say UV number 1 and 2 has chosen slot 4 for transmission, and UV3 has chosen 6 for transmission. Whereas 1 and 9, there is no transmission from any UVs. But G0B doesn't know when the UV is going to transmit the PRACH on which slots and all. So G0B has to go and perform the PRACH detection across all these slots 1, 4, 6, 9. Okay. Whenever it performs a detection, it will first do PRACH. It will first do frequency domain correlation. Okay, so the incoming IQ will be correlated with the frequency domain sequence, and then it will be given to time domain conversion and power calculation, and then finally a PUSCH algorithm will be running to provide whether preamble ID is detected or not, and what is the, if detected, what is the timing advance corresponding to that preamble ID. So this process has to happen for every preamble ID. Okay, G0B will try out for all the preamble IDs, and it will see across which preamble ID there will be a good peak. Okay, or there will be a good correlation. If you want to know more details about this PRACH detector, especially I have given a technical presentation, even considering ZCZC parameter, because the detection algorithm will become a little bit complex with the ZCZC. So I will put up all these details in the description box. So if you're interested to opt for this, you can go ahead and take this presentation. Okay. Now coming to the G0B detection. So just before the peak search algorithm, or as part of peak search algorithm, so let us say G0B initially tried with preamble ID number 1 because UV1 has transmitted preamble ID number 1, right? So definitely the correlation will be good. And if you try to plot the power versus samples just before peak search algorithm, then you would see that since the correlation is good, there is a definite peak at certain point. So let's say maybe TD1 is the delay. After that delay, there is a good peak because of good correlation. Definitely, these samples are in discrete domain, but the plot, just I'm giving the plot in a continuous fashion so that it is easy for understanding purpose. Now, peak search algorithm will say whether this peak is valid or not. It will tell based on the threshold value which we are setting it in the PRACH detector. So this design of threshold value is the main part in the PRACH detection. That's why I have brought up this particular video. So how to set this threshold? Definitely, we have to do a lot of simulations in the MATLAB and try out various scenarios, various power values, and various delays, various distance from the base station, and then we need to arrive at this threshold. Okay. But there are certain criteria to choose this threshold. That is what we will conclude by the end of this video. Okay. Now let us say we have this scenario, and now we have got this peak, and let us say this peak value is, let's say 10. Now we can say that this threshold number 1 could be 8. Okay. For example, in the beginning we will set it to 8. But now, if you go to other scenario, second preamble ID scenario where UV2 has transmitted preamble ID number 2. Now when G0B performs the correlation, for this also we will get good correlation, but UV2 is a little bit farther, right? So its power is low. Definitely, so the peak will be of low power. So you can see here in this plot, I have given the green plot. Green plot is having a definite peak, but its value is 7. Okay, so let us say the delay corresponding to that is TD2, because even delay is also, this UV is further distance, even this delay is higher compared to that of TD1. Now, if you see, earlier we have set the threshold to 8, right? 8, but whereas the peak is at 7, definitely whatever the threshold we have chosen in the first place, that is not covering the peak of second UV, right? So then definitely this calls for this will give the hint to us that we need to lower your threshold. Let us say I will lower the threshold number 2. Let us say I will make it to 6. Then if you set it to 6, then UV number 1 is also covered, UV number 2 is also covered. Then both of them will be detected. And so one criteria would be like, when choosing this threshold, it should cover more and more UVs, even though the UVs are having a little bit low power, and also as well as if UV is transmitting the BS from a longer distance, definitely its power will be low. So give a chance for those UVs also to get detected in the first attempt only. So for that reason, the threshold should be as low as possible. Okay. Right now, don't get confused here. Right now, I have given the plot for second PMLID in the same plot where the correlation was done for the first PMLID. So for the sake of better understanding, I am just overlapping the plots for two UVs. Okay. So now let us also consider the third preamble ID for UV number 3. Okay, so this UV number 3 is still further distance, right? So definitely here blue. I have given the blue color. So this blue color plot, let us say this is the 1. Let's say this is at 5. This is the definite peak we have, and for corresponding to that, the delay is TD3. Now the thing is, this is not covered by threshold number 2, right? If you want to cover, okay, one it is go below. So let us say you choose 4 or something, then make it threshold number 3. And but if you take threshold number 3, you will see that it is not only detecting the blue color peak, but some unwanted peak from first UV is also seen here. Okay, so this will result in a false detection and or fake detection. So definitely threshold number 3 we cannot set it. So we have to leave it to threshold number 2. In this case, as per this observation, in this case we have to definitely skip the selection of or detection of PMLID number 3. Okay, because if you try to lower the threshold, then it is also detecting some more false peaks, right? So that is the reason. But what will happen for UV number 3? Since UV number 3 PMLID is not detected, after some time UV number 3 will try to transmit the PRACH with higher power. Okay, in which case the peak would cross more than the threshold of more than the threshold, that is threshold number 2. That time in the second attempt or third attempt, even UV number 3 will also be attached to the cell. Okay, but in the first attempt, yeah, as per this design, as per this threshold value, it is not possible to select. Okay, so based on this, what are the main considerations for designing the threshold? So one thing is you need to have the threshold as much low as possible, so that you can do more and more detection. I mean, you can detect more PMLIDs even if the UVs are at a larger distance, or even if the UVs are coming with low power. But another important aspect to consider is the threshold value should avoid the false detection. It should be high enough such a way that it will not detect any false PMLIDs. Okay, so these are the two things as of now. With this, I would like to conclude. In the upcoming video, I will try to see what are the other parameters that could affect this threshold. Okay, whether we can have similar threshold for all the formats or not, whether we can have much lower thresholds for certain formats and things like that. And also I will talk about what is the role of repetitions in deciding this particular threshold design. Okay, see you in the next video. Till then, bye bye.